We're going to begin by reviewing all the integration we've ever done. The reason I like this is if you look at problem number 1, look at all 3 of those problems. They all look extremely similar, except I keep inserting an additional x into the numerator each time, and that makes the problems wildly different. Let's start with part A. Part A, you would usually try to use sub first, but you can't, and then you quickly realize, oh man, I can turn that into an arctan. Unfortunately, you have a plus 4 and it needs to be a plus 1, so you've got to divide everything by 4 first. No problem, it's done. And to make it look more like the arctan formula, I went ahead and switched the denominator around, putting the 1 first. All right, next up we need a u sub. In fact, we're going to make a 3-step u sub. Remember, this has to look like 1 plus u squared, so the u squared becomes x squared over 4. U will be x over 2, and then, of course, du becomes 1/2 dx. Just to get some more space, I slid that up a little bit. Now, notice that we need a 1/2 dx, so if I give myself a 1/2 here, I have to put a 2 out front. Okay, so this will become a du. The 9/4 will come out. Doubling that will make a 9/2. And now it looks exactly the way we want it to. The answer is going to be 9/2 arctan of u plus c. Of course, we want to put the u back in, which is x over 2. So it's 9/2 arctan of 1/2 x plus c. That'll be the final answer. Okay, so we have an arctan problem. However, we're in chapter 8. When we were in the arctan section, you knew everything was going to be arctan or arcsine or arcsecant, so we anticipated it. But here we have to kind of come up with it on our own, mixed in with all the other things that we learned during the year. Back up to the top, you can see in part B that will not be an arctan problem because you have that extra x up top. Instead, this is just a conventional u sub. I would make u the x squared plus 4, and that will form du as 2x dx. We can kick the 9 out, give ourselves the 2, divide by 2 out there, so we have a 9/2, and then the 2x dx will become du, and you'll have 1 over u, and this is going to turn into a natural log. So look at the difference. The difference between not having an x and having the extra x turns an arctan into a natural log. That's crazy. So again, we're mixing all the sections together, really keeping you on your toes. And this forms a great review for the end of the year. I think this is a great section, just the fact that we patched it all together. So again, 9/2 integral of 1 over u du, which is 9/2 natural log of u, and the u is going to be x squared plus 4. And again, what a difference one little x makes in the way that we attack a problem. Those answers couldn't be more different from each other, other than the 9/2 and the plus c's. I wonder what would happen if I just threw one more x in the numerator. Made it 9x squared. Let's find out. We've used arctan. We've used natural log. We've u subbed both of them. This one's going to be neither. It's not partial fractions, because we can't factor the denominator. You know what? Since numerator and denominator have equal powers or the same degree, we're going to need to use long division. And since we're going to need long division, I'm going to need some more space. So I'm going to move to another page. All right, let's long divide. In this instance, it would be tempting to put the x squared plus 4 inside, but it is in the denominator, so actually it is the divisor. It's on the outside. All right, so we look at the first term in each. This only has one term, so we'll look at it. And you say, x squared times what is 9x squared? And obviously the answer is 9. It's not much of a long division, which is cool. All right, that's 9x squared plus 36. And the tried and true catchphrase, draw the line, change the signs. That cancels, but we have a remainder of negative 36, or minus 36. over x squared plus 4. So what's going to happen to this problem is I'll just rewrite the original. Instead of this, we have this. All right, the integral of 9, of course, is 9x minus, I swear we just integrated this on the front page, except instead of a 36 on the top, it was a 9 on the top. That was part A. So I'll just steal the answer to part A and just multiply it by 4 since we have an extra times 4. What was the answer to part A? It was 9/2 arctan of x over 2. Okay. Okay, so that red stuff was the answer to part A. But again, part A had a 9 on top, not a 36, so I have to quadruple this. Plus C. This 4 and this 2 will cancel. That's going to be an 18 in there. So part C had long division, and then it turned into a partial arctan. So again, this is a great all-encompassing review of basically your entire second semester of college integration. We'll try something similar here in number 2. There's no part C, just an A and B this time. But again, they are so similar. One has a 4x, one doesn't have the x, just a 4. Very different approach. Let's do part A. I can u sub this. And I think we're a lot better than we used to be when we first learned this. I can tell, I see the squared, I see the first power. I know that a u sub is possible. We're in part B, I see the squared. I don't see an x to the first. And I'm thinking that's going to be more inverse trig-ish. And it will be. All right, so I've made my u sub. I need an negative 18x dx. So here's the negative 18. I'll divide by negative 18 out here. The 4 is going to come out, become part of the fraction. And now this negative 18x dx becomes the du. Negative 4/18 is the same as negative 2/9 if you reduce it. And now we have u to the negative 1/2 power du. All right, here we go, negative 2/9. U to the negative 1/2, up by a power, that's u to the 1/2. Divide by the new power, that's times 2. All right, we're going to have a final answer of negative 4/9. U to the 1/2, which you can write u to the 1/2. The book might actually put it back in a square root, just for fun, plus C. Again, don't be that person that takes this and says, oh, perfect squares, 1 and 9. I'll make it 1 minus 3x instead. That's bad algebra. Don't do that. If you take 1 minus 3x and you check yourself, sure, 1 times 1 is 1, but negative times negative is positive. You don't want a positive. You want a minus. And worse yet, you have another negative 6x that you don't want to deal with. So no, don't do any of that green stuff. Leave that out. There, that's much better. Okay, part B, like I said, this cannot be u subbed. So instead, we have to do the next best thing and go inverse trig. Actually, I guess you still are u subbing it. It's just a 3-step u sub instead of the conventional one. So u squared becomes what I've underlined. U is the square root of that, so 3x. And then du is 3 dx. I happen to have a 4 dx, so we'll get rid of the 4. And I'll give myself the 3 that I want. Divide by 3 out front. So we have 4/3. Integral. That's a du. The rest of this in the box is 1 over the square root of 1 minus u squared, which we know is arc sine or inverse sine of u. So the answer here is going to be 4/3 inverse sine of u, which is 3x, plus c. And again, almost an identical original problem. The only difference is one little x in the problem, and look at what it does to the answers. So this really tests your knowledge. Okay, number 3. At first I look at this and think it's a u sub. If I made the bottom, or at least the 1 minus x squared u, du would be negative 2x dx. I can't make that work. And I can't make it into, the other thing I thought about is, well, what about an inverse trig? What if I made an arc sine? But then you've got that 4x minus 3 on the top still. That's no good. You can't have that. So the only thing we can do is kind of do a little bit of both. We can split this into 2 separate integrals. Let me show you. How about that? We're not used to splitting common denominators. Usually we're used to putting them together, but this is what we need to do. Now we can do what I was hoping for. You can u sub this, and we will in a moment. And this second part is going to be arc sine or inverse sine. So, okay. All right, let's try the first part. The u in this case would be 1 minus x squared, as I mentioned, making du negative 2x dx. I'll just hit the inside with a negative 1/2, the outside with a negative 2. That'll turn this into a negative 2x dx right there. So this is going to turn into negative 2 u to the negative 1/2 du. Okay, more on that later. Subtraction sign drops down. I can just kick the 3 out. And when I kick the 3 out, it's a 1. And I'm just staring at the exact formula for arc sine of x, or inverse sine of x. So that's already been integrated. All we need to do now is just finish the red portion and we're done. We have not integrated that part yet. Okay, up by a power, so that'll be u to the 1/2. Multiply by 2. There's already a negative 2 in front. Okay, that's going to become negative 4. I think I can just write the final answer. Negative 4 u to the 1/2. Again, 1/2 can also be written as a square root. It's up to you. You can leave it as a 1/2 power. That's fine. And then we just bring the rest of it down. And that's going to be the final answer. Hey, let's do some trig. I've got the natural log of tangent of x, which really ought to probably have absolute value around it. That's my bad. Over sine of x cos x dx. And it's true that tangent is sine over cosine, but really the sine and cosine are in the denominator, so they're not even sines and cosines. Really, it's a secant and a cosecant. Ew. All right, I've got to figure out what in the world I can do with this. I was thinking about maybe making tangent of x the u, but the derivative of tangent is secant squared. I only have one secant. The other one's a cosecant, so that's no good. What if I made u natural log of tangent of x, just like the whole thing? Well, then du, I think this through, would be 1 over stuff, so it'd be 1 over tangent. I'll leave the absolute value off since it's not being logged anymore. Times a chain rule, and the derivative of tangent, of course, as I mentioned, is secant squared of x dx. We might have a chance here. This is what we need. Do we have it? 1 over tangent, this is why pre-calc is so helpful. 1 over tangent would be cosine over sine. All right, secant squared is going to be 1 over cos squared. And you know what? You can cancel this cosine with the squared. And look at that. Du is actually 1 over sine x cos x dx, which is actually exactly what I had right here in my original problems. I don't even need to do my rewrite. I'm going to get rid of that. So this just turns into the integral of u du. Oh my gosh, which is u to the first if you prefer. Up by a power divided by the new power, that's 1/2 u squared plus c. But again, never leave a u in your answer. And that is the proper integral for number 4. Here's number 5. I see 9 minus x to the 12th. 12th is a very large exponent. I'm suspicious of it, and I'm thinking inverse trig. I don't like that 9. It needs to be a 1, so I'm going to factor out a radical 9. Of course, that square root of 9 is just a 3, which will cancel the other 3 in the numerator. Fantastic. All right, let's turn this into u squared. That'll make u x to the 6th over 3. And since that is 1/3 x to the 6th, du will be 2x to the 5th dx. All right, so I need a 2x to the 5th. I'll put a 2 on here, 1/2 out front. The 2x to the 5th and this dx that I've circled will become this here du. 1/2 integral, and I'm left with just a 1 on top, so 1 over exactly what I wanted. Yeah. And so that's just going to come out to 1/2 arc sine of u plus c. Remember that u is x to the 6th over 3. And now we're good.